I'm going to just put this on the recording as well, just to reiterate that I haven't taught Unit 8, which is your defense and repair and energy imbalances. So it's something that I'm not 100% familiar with. I know the working knowledge as an NT and what I've read for RA and MACFS, and I did go back, of course, to put this PowerPoint together, but I know that some of the little bits, I won't be as clear as Jess was, because she's phenomenal in her knowledge of the immune system. So if I don't answer your question sufficiently tonight, please just post under your question on the form again. And what I'll do is I will answer you in written format on the form. So you will get your answer for definite. And then we will go through the immune system again next year, because I'll be your unit leader for Unit 6, which is the immune imbalances one. So by then I will be an immune expert before I see you. And just for some of you that asked, I know Darren, I think you asked about estrogen detoxification. There was a couple of questions about bile. And I know Patricia, you asked a few about hypochlorhydria. What I'll do is I'll do that Saturday morning. So we've, I think, 2.25 hours or 2.5 hours set aside Saturday morning to go through assimilation, biotransformation, and communication imbalances. So between now and then, stick up any of your questions that you have on those. Use that time, you know. Obviously, they're more my areas because that's what I lectured you guys this year. And the hormones is what I've been doing for the last 4 years. So I've no problem going through estrogen detoxification. And it's also a really nice one to bring to life phase 1 and phase 2 detoxification in one workable model as well. So the tutorials, what I've done is I've put all your questions into a PowerPoint and then the answers. Some of the answers are taken from Unit 8 PowerPoint. Some of them are the clinical imbalances summary PowerPoint, and some of them is new material. Where it's new material, I've tried to put the font in green, and I will upload this in PowerPoint format for you guys tomorrow as well when the recording goes up. So you don't have to, you know, don't be frantically writing. I'm going to give this to you tomorrow. Even though some of it you have, some of it you don't. There's 1 or 2 new pictures in there that I thought might be beneficial as well. Some of the questions, just a forewarning, are a little bit too in depth for what the course is. It's beyond the remit of the course really. So I'm going to flag that to you there. But what I've done is one of the questions, I think was Linda, was the follicular cells, was it the TFH cells? That really is beyond the level of this course, which is why the material wasn't included. But I've put in 1 or 2 little lines for you anyway. I went and did some reading. So without further ado, we'll get started. And please always just stop and ask, because there's only a small group, so feel free to unmute yourself. So I said we'll start with this energy, because there was only just Jill was asking me to go through the Krebs cycle, which is really important before MECFS. And you will see in the MECFS PowerPoint, Moira's gone through it. There's the audio, and I will go through it again if you need on Saturday. So that's another thing you can put up on the forum again and say, look, can you just go through some of this? Because some of the research on MECFS and the functional medicine approach is really linked to energy. So we're going to focus a lot on it in the MECFS. So if it's not clear 100% tonight, we'll do it again. And then there's going to be another tutorial, don't forget, right at the end with Moira on MECFS and assessment 3. So you'll get another run of it, because I know for me as a practitioner, so this is because I haven't lectured this yet, as a practitioner, to me, energy production is very much that I know it's ATP. I know that we use the glucose, the fatty acids, glycerol and protein. You know, that's kind of the basics. Then we know that ATP is produced, and we know what the cofactors are. And the most important cofactors that as a practitioner I would always focus on is B vitamins and magnesium. CoQ10, and there's a couple of others, iron is another one that you'll come across, but really the main ones we would focus on are B vitamins and magnesium. And then if somebody's on a statin, so this is a little heads up when you're a practitioner, and we would look at CoQ10 a lot, because statins deplete CoQ10, which unfortunately most doctors are not aware of, even though it actually says it as far as I'm aware in the statin insert. Some of the clinics and doctors are prescribing them. So I know from having worked in a health food shop before lockdown, that we had some people would come in and they'd say, I'm looking for CoQ10 because I'm taking a statin. But the vast majority of doctors don't know this. So it's something for you to be aware as a practitioner. And it's because of the mitochondria requiring CoQ10 to make energy. So that's why you need to be aware of it. And just for example, the Beacon Hospital in Dublin, they actually, when they prescribe somebody statins, they prescribe them CoQ10 straight away. And I know a lot of the pharmacies in Kildare, if you go in with a prescription for a statin, they will recommend CoQ10. So that's actually totally out there in the biomedical model. So really important for you guys to know as well. The reason I say this is what I know as a practitioner is that I want to be mindful of that you don't get too reductionist. And especially some of the questions on the immune system, to me, we're getting very specific into like focusing on one type of cell. And that's not realistic when you're an NT practitioner, because you're dealing with the big picture. And the problem with the biomedical model a lot of the time is it's too reductionist. So it's like people who focus only on, really good example actually is COVID-19. They focus only on one nutrient and they think that's it. That's the most important thing for the immune system. Well, it's not. You know, in nature, we have a whole host of things and they're in food. And it's why singling out nutrients isn't great, because in the food, they're all synergistic. They're in the right ratio. Like if you think eating kale, which is often considered a superfood, or broccoli or spinach, it's not just for calcium. There's iodine, there's magnesium, there's zinc, there is, you know what I mean? Like there's loads of different minerals, there's vitamins, there's phytonutrients, there's glucosinolates, there's sulforaphane, there's so much in there. So it's a little bit the same with these systems. Don't forget to take a step back and look at the whole instead of focusing on just one thing. Of course, we have to teach you the little nitty gritty because you have to understand it. But as a working practitioner, you're not going to be looking at that level unless you do specific testing. So if you do the testing, like if you do oat tests, fair enough, then you are going to look at specific metabolites. And I'll mention that to you at the weekend. If I can remember to bring an example of an oat test, I will. So just a little forewarning. So it's a little bit the same with the Krebs cycle. You know, most of us practitioners won't be able to tell you all the different parts of the Krebs cycle. So let that sink in. We don't know. We would go and look it up, okay? So the recent NTY AGM was held online and we had a lady on and she talked about the organic acid test, the oat test, which is all about metabolites. And honestly, like this is after me preparing for Unit 11 and I wish I could have hit pause because she was throwing out all these words. Now, a lot of them I knew because I just studied this unit and I was like, oh yeah, carnitine is for fatty acid metabolism for the Krebs cycle. Yeah, gotcha. But if I hadn't just done Unit 11, I wouldn't have known half of what she was saying. And that's normal. And all my colleagues said the exact same thing, unless they're lecturers or they're doing the organic acid tests all the time. So just for anybody who's feeling a little bit overwhelmed, I just kind of really want to stress that. Please don't worry. So a couple of the things I put in is just the big picture here that we use are basically your macronutrients, your lipids, your carbohydrates and your proteins to make energy. Of course, they're broken down into different steps. So for example, we have glycolysis, we have fatty acid oxidation. Then we need to bring pyruvic acid or pyruvate down into acetyl coenzyme A, and that's the link reaction. We will go through this in MACFS PowerPoint. There's a lot of information in there, and Moira's done a really good audio over all these little reactions, the cofactors that are necessary, the nutrients that are there. So it's just really just to remind you of all the versions or all the ways that we have to make energy in the mitochondria. Number one important thing. So then the Krebs cycle. Number two important thing is that it can be called the citric acid cycle or the TCA cycle. So it has three names and you'll find all the different diagrams or the different websites will call it different things. So some of you might have heard, because I remember being really confused about this as a student. So I would think, well, okay, that's the Krebs cycle. I understand the Krebs cycle. We make ATP, you know, there's FAD and NAD and it goes on to the electron chain, your ETC. And then somebody said the TCA cycle, and I thought, oh my gosh, I have no idea what that is. I better go study it, not realizing it was the same thing. So I'm just flagging it to you again in case it's something that's been buried in your subconscious since Unit 8. So the citric acid cycle, if you look there, there's two different diagrams. One is much more detailed than the other. The other one is more slim, has kind of the basics in it. And to me, a practitioner really needs to know the one on the right, okay? So you need to know about your pyruvate being turned into acetyl-CoA. That goes into your Krebs cycle. Then you have NAD and FAD being converted, because the important thing there is the extra hydrogen molecules, because that's what's going to power your transport chain. I have an issue with that. And that there's ATP produced. That's kind of the important bit as a practitioner. Now, to understand the nitty gritty, you do need to know a little bit more, especially if you're looking at the underlying enzymes, which is one of Jill's questions as well, to look at the toxins, which is where you want to maybe look at the left-hand side diagram, for example, where citrate is being converted to isocitrate, because it's that step that might not be happening in people with ME/CFS, or when they're exposed to certain heavy metals or medications. So that's one of the enzymes, the one that I have it listed on the next page. The one that converts citrate to isocitrate could be affected, for example. And there's other steps in this cycle that mightn't work. So for example, if you can't go from succinate to fumarate, or fumarate to malate, like there could be SNPs there. But again, without doing any testing, you don't know that. You're just guessing. And there is that saying that we have, I bring it up in P&T Unit 8, test, don't guess. And it's really important when it comes to metabolites, because there's so many potential metabolites, there's so many potential SNPs, that unless you test, you just don't know.
Sorry, Gwen, Patricia here, how are you?
Hiya.
Can I ask you something really quick there? I was looking into CoQ10 supplements, and some of them came with this extra selling point, you know, with extra mitochondrial support because they included fumarate.
Okay, yeah.
And then I was like, why fumarate instead of succinate or malate? What's the crack with fumarate, if you don't mind me asking?
Do you know what? Some of them, there's different ones. Like you could take, for example, it's a good question. Again, it depends on where in the cycle, because it's a cycle. Mm-hmm. And this is the important thing to remember. And one of the reasons I don't get too stuck in the nitty gritty, because as long as you help somewhere along the cycle, you'll help the rest of the cycle.
Okay, good.
Because it's a cycle, you know? Mm-hmm. It's like estrogen dominance that we've done a lot. And I know I've said it to you already in Unit 9, and you'll keep hearing me say it in PNT. It's a vicious cycle. When you have inflammation and you have estrogen, you keep having both, because one influences the other, influences the other, influences the other. And it's a bit like that here. So if you can go in and help with malate, well, then you'll help with oxaloacetate, which will help with citrate. If you help with fumarate, you'll help malate.
It might be just easier to obtain fumarate then.
That's exactly what I was going to say, that certain parts of this are much easier to get and cheaper.
Okay.
So yeah, you can get CoQ10 on its own. You can get different formulations. For example, malate, you can get a really nice thing called magnesium malate.
Yes.
So then you're doing two things at the same time. You're giving somebody malate and magnesium. So for people where you think energy production is an issue, magnesium malate would be a really nice supplement to go in with.
Yeah, it's the same as magnesium glycinate as well. That comes with the glycine, or whatever you call it, you know?
Yeah. So magnesium glycinate, for example, is really lovely for hormone balancing, because you're putting in glycine for biotransformation. Mm-hmm. So there's often the clever supplement companies will put things either synergistically. So Terra Nova is a really good example. They're B complex and vitamin C. So when we're stressed, we need more vitamin C. When we're stressed, we use up more B vitamins. When we're tired, we need B vitamins. So they've done B vitamins and C, but they've put in adaptogenic herbs like rhodiola, which are really good for calming the stress response.
Yes.
So, you know, so some companies are just very smart in what they do. And personally, unless it's a very specific nutrient, I go for the complexes, the synergists, because of exactly this. you can do two things with magnesium malate. You know, you can intervene in two different places, for example, with energy production, or magnesium glycinate, if you can get something like that. So that was a good question.
Oh, thank you. It was a perfect answer. Thanks. Very nice. Thank you.
You.
Without sleeping and everything.
Yeah, well, that's okay. And I put in a little reminder then as well of what is actually produced with the Krebs cycle. Again, do you think you need to remember that for the rest of your life? No. It is important to understand when we go and look at the pathophysiology of MECFS, then you do, if I say NAD and FAD, you need to have an idea in your head what they are. But again, Moira did them beautifully in the MECFS PowerPoint. So you don't have to listen, and I would recommend you don't listen to the videos or the audios of the Unit 11 PowerPoints yet. I would suggest you just skim the PowerPoints, we do the lecture weekend, and then you go and listen to the recordings as a really nice revision. But you'll find it's done really well. She's done it in two different places where she's done glycolysis, link reaction, Krebs cycle, the ETC. She's done it step by step twice. So it's really well laid out. But yeah, I wanted to flag to you, don't get bogged down with one little bit, because I wouldn't remember all of these. If you then go and you do a test like the organic acids test that actually looks at the metabolites, and each metabolite will tell you, well, this measures ketoglutarate, or this measures fumarate, then you need to go and look at the details of the Krebs cycle again, you know, but not as a general practitioner. It's just important to know, for example, which is the next page, that some toxins or fluoride, for example, can have an impact on citrate synthase, which is the one that I just said to you converts the, oh my gosh, now I've forgotten, the two first to the isocitrate, the first two steps on the Krebs cycle. So they can actually stop that enzyme from working. And if, just like we said, if you put fumarate or malate, if you help anywhere along the cycle, it helps it run. Well, if you block anywhere along the cycle, it stops it working. So if an enzyme isn't working because that person has fluoride in their drinking water and maybe fluoride in their toothpaste, and maybe they're boiling that water and they're condensing that fluoride even more, and they're drinking 8 cups of green tea because they think they're doing something great a day, then maybe they're going to have an enzyme that's not working in the Krebs cycle. Again, though, as a practitioner, you'll be aware you don't want fluoride for the thyroid anyway. So if somebody comes to you and they're really tired and you're thinking, mitochondrial dysfunction, you know, is it in the Krebs cycle or is it thyroid? Well, let's just get rid of fluoride. And whichever one of the two it helps, they're going to have more energy. So that's what I would find as a practitioner anyway. A lot of it, if you're not testing and you do have to guess, then you make the guesses that will have an impact on a few different places. And that would be one of the things. Well, if I take out the toxins, I'll help energy production, I will definitely reduce toxic load and support the liver, and I'll help the thyroid function, which means metabolism will work better. You know, so by removing fluoride and arsenic, for example, you'll help 3 things at the same time. So that's just an example of the enzymes that are there. There are other ones as well. One of the important things to remember actually is that, and again, this has gone into in more detail in MECFS as well, is that some of the antioxidant enzymes unfortunately also get affected by toxins and medications and things. The problem is there's not a huge amount of research done on this. So this is a little bit where there's 1 or 2 case studies, small time studies, and we don't have the huge amount of research available that we might like. So it's kind of, you're using evidence-based, but it's kind of case of this has been working for other practitioners. Here's the test that shows this metabolite is low maybe, you know, in that Krebs cycle. And then you say, well, okay, I know fluoride has an impact, so maybe I remove fluoride and I retest in 3 months to 6 months. Unfortunately, some of the metabolites can take like a year to improve, which is a long time, but anyway. Then there's some of the herbicides that were in the PowerPoint. So they can have an impact on the ETC, which is not good, because if you have the Krebs cycle working, but then there's kind of, it's blocked further up, then you still don't have the energy, you know? So you really want everything working at the same time. And then the problem is that if the ETC isn't working properly, we get a buildup of reactive oxygen species. So you have your oxidative stress. And of course, what does oxidative stress do? Well, it's going to deplete antioxidants and then go and cause tissue damage. That will cause an immune reaction. So it's like this spiral out of control, which is why we want to make sure everything is working as it should be. A little bit of oxidative stress is normal, and that's where the body has the antioxidant system and it has the enzymes. But if there's too much, then we end up with that big, big problem. And then it has this, like just a spiral effect all over the body, really. If there's damage to the mitochondrial DNA, that's not good. And that can happen in two ways. It can be through oxidative stress, because we know oxidative stress, and ROS in particular, damage DNA. So that can be contribute to damaging specifically the mitochondrial DNA, which is not good because then your mitochondria won't function. But also, of course, it can start leading to cancer development as well. So something we really don't want. And then toxins can also damage the mitochondrial DNA. And just think about if there are loads and loads of little bits of damaged cell floating around in the body, well, what happens? The immune system gets activated, and this is where your DAMPs come into, which we'll talk about in a little bit. And they go, oh, danger, danger, because it's the danger system, right? I found a really nice diagram for you guys. And then you end up with this immune cascade of cytokine production. And it was simply the fact that some DNA got damaged because of a toxin, but you're ending up with a huge immune response, which can contribute to acute inflammation. And as you are well aware, having studied all this material, if there's nothing done about that, it can continue into systemic chronic inflammation, which underlies pretty much all the chronic diseases. Like if you look at the matrix for any big disease, any big condition that you've studied so far or you're going to see in the future, inflammation is always there. Always. Like an example is all the estrogen dominant conditions, fibroids, endometriosis, anything with an is at the end is inflammatory, but all those conditions, inflammation is there. That is why the immune system is really, really important, unfortunately, to some of us. And then I've already mentioned that free radicals can have an impact on the electron transport chain as well. So I don't know if that's made it a little bit clearer, Jill. If not, let me know. But like I said, it will be covered again twice.
No, that's great. Thanks very much.
But honestly, even if for any of you who had questions, if after tonight, like say tomorrow morning, you're sitting there and you're going, yeah, I wasn't quite sure, just under your own question on the thread, just put another comment, because I'll be checking tomorrow and Wednesday and Friday. And I will answer, because I know it's a lot to take in sometimes. And sometimes when you're just writing the question, it's not fully clear to me what answer you're looking for either. So we'll move on into the immune system. And there's a ton of questions on the immune system. And like I said, I'll do my best. But again, I want to say from a practitioner point of view, for me, it's very much inflammation underlies all the big conditions. What are the triggers? What are the mediators? And the mediators in inflammation are just so, so important. So it's your cytokines, really. And what can you do about them? And that's PNT very much. You will learn that in Unit 6. Well, we'll learn it together. We'll do it. And you'll see it'll run through the other units as well, because it really is involved in absolutely everything. So reducing inflammation and promoting anti-inflammatory reactions in the body. That's kind of the important thing as a practitioner. Unless you, of course, specialize in immune conditions or you want to go on and study immunology or anything like that. But just, again, take a step back and think, well, I'm a functional medicine practitioner, so I want to look at it from the imbalances point of view. So you're looking at an imbalance in the immune system rather than one specific cell. And I think if I can get that kind of in your heads, yes, the detail is really important and you have to learn it to understand it, but then you take that step back and you zoom out and you look at the big picture. It's a little bit like with the hormones. Don't focus on one hormone because they all have an impact on each other. Like if you only ever focus on estrogen, you are not going to help your client, because you need to look at cortisol and consider DHEA, and really you need to look at the thyroid and progesterone as well, and potentially testosterone. So this is a bit the same in the immune system. So anyway, without further ado, So the first question I got, and thank you, Anne-Marie, for starting it off, is about the adverse food reactions and atopic conditions. So what I taught myself was, because this is something that I know when we studied, the terminology can be a bit wishy-washy and different people use different terminologies. And I know myself, when I've used a word, I've had people absolutely shoot me down on social media or when you're doing a talk or something. So I've got very clear on my own terminology that I use, and I went and double checked it on a couple of places for you guys as well. And to me, I think this is a good standard to stick to. So if we're talking about a food allergy, we're talking about an IgE mediated reaction. So it's a hypersensitivity, and very often it's anaphylaxis. So this is the worst of the worst. Think peanuts. That's the way I kind of reminded myself. It's the throat closing and somebody needs to get to hospital ASAP, or they need their EpiPen, right? That's kind of how I remember the IgE one. Then you have your food sensitivity. Now, when we did this was called a delayed allergic reaction. So that was the terminology I used. And people got very offended by it, because especially people who said, well, because I would have this to dairy. And people would say, well, do you need to carry an EpiPen? And I said, I don't. And they said, well, then you're not allergic. So I just kind of said, fair enough. And I think it's good now to see the newer terminology. I think it's clear, saying food sensitivity. Now, it is still mediated by immunoglobulins, IgG and IgA, which is why the tests for these, now these are often called food intolerance tests, and I think that's where they're wrong. They should be called a food sensitivity test. They look for IgG or IgA. So myself, I would have done an IgG test for these, and it was dairy. Well, 20 foods came up, but anyway. So the most common one that we're familiar with is usually IgG. But IgA also is involved. So it's where the symptoms are delayed, which is why they would say delayed allergic reaction. So it can be the sick stomach. People can get migraines. That's really common. You know, some people would get diarrhea. To me, I would always say if I eat dairy, it's like a washing machine. I get really nauseous and my stomach just feels like everything's churning around. So if I eat dairy, I eat it at night and I go to bed. And then I'm grand the next morning. And I can have my tiramisu every once in a while. But that's usually a food sensitivity. And to me, the important distinction between a food sensitivity and a food intolerance is, with a food intolerance, if you, for example, the classic one, which would be lactose intolerance, because you're missing the enzyme lactase, if you take that enzyme or the other digestive enzymes, you are fine and you can eat that food fine. Well, that to me, that shows that's not associated with the immune system at all. If the only thing you've done is taken a digestive enzyme, well, then it's not an immune response. And that to me is kind of how I divide them up in my head. Now we'll show on another slide, there is that other part of it where people might be sensitive to, gluten's a good one, because where you kind of think, well, where does gluten fall? Where does wheat fall? And for myself, I'm fine with gluten, but I have an issue with wheat, yet I'm okay with organic wheat. So to me, it's the pesticides, you know, the glyphosate, which is being found all over in every cereal, you know, cornflakes, baby rice, baby cereal, Weetabix. It's been found in everything. So that would make more sense to me, but that isn't the classic food issues or food adverse reactions that we're talking about. We're talking about allergy, which is IgE, and think of your anaphylaxis. Then we have IgG or IgA, which is like a delayed response, and it's not as severe. I mean, the people can feel really, really unwell, but they don't need to go to hospital. And then you have your food intolerance, which is usually not associated with the immune system and very often is a lack of a digestive enzyme. This is a slide you already have. I think it's a really nice one to put back in there. And of course, one of the things that we have to remember, which is celiac disease, which would be autoimmune. And then there's just example of the IgE ones. And like I said, it's the anaphylaxis, or it's the you know, the tongue swelling up, streaming nose, sneezing, that kind of stuff. But some of these can also be in the IgG mediated, which is your sensitivity rather than allergy. And like I said, it's that washing machine, the diarrhea. People get congested. You know, people who have extra mucus when they have dairy, they would go in there for me. And it can be joints. So people with RA, I've had clients with RA that if they go off dairy, their symptoms abate hugely. But it's not a case, they mightn't have recognized it beforehand. You know, it's only when they actually go off the dairy that they say, oh, my joints have actually, they're not swollen. And they send me, one client sent me photos before a 6-week dairy elimination and after, and it was phenomenal. The size of it was her wrists. Little things like being tired, feeling dizzy, like they can be very small symptoms. They're really hard to pinpoint, but they could be a food sensitivity. And then you have your food intolerance on the right-hand side, which is your non-immune. And like I said, it could be the enzyme deficiency, but then there can be non-specific reactions. But very often they would be because there's intestinal permeability present, or there's other stuff going on. You know, with IBS, there might be, for example, serotonin. People can just be more sensitive because they have too much serotonin, for example, so they get diarrhea. So that's not actually the immune system so as much as something else. And then some people could have an intolerance to caffeine. That's really quite common, actually. And it makes me laugh. You know, you have some people that they have a really big meal, they have a shot of espresso and they'll run to the toilet within 5 minutes. I have a friend who does that. And it's really funny because it's like clockwork. You know, I see that person drink a coffee and I can literally time it. And next thing they're gone and completely empty their bowels. So like, some people think that's great. You know, they're like, oh, I've emptied my bowel. And I'm like, 5 minutes is not, you know, it's not great. But often that one I would say will show up in the liver as well. They'll have palpitations. They'll have other signs and symptoms of maybe a high phase 1, low phase 2. So that can be, again, it's not the immune system, basically is what I'm trying to say. There could be another reason for it. It's not the area I know most about, to be honest, but we know it's there. And an interesting one there is with people, if they don't drink coffee, they think they're fine. But I would always ask them, well, how do you feel when you eat dark chocolate or raw cacao? Because I have know people, practitioners, who couldn't eat raw cacao brownies because they would just have palpitations and they have a really severe reaction as well. So that there could be what would be classified as a non-immune mediated food intolerance. So this is a really good slide, I think, to have. So what I did was I tried to reword some of the words, the text. What I did when you see text in green is what I've put in new stuff. Now, because there was so many questions, and I did spend nearly 6 hours on this, I did a lot of quotations, which is a no-no in academic writing, and I'm owning it. I just didn't have the time to go in and put everything in my own words. But I've given you the references because I figured those of you who asked the specific questions might appreciate the extra link. And some of you mightn't even have thought of asking these questions and are now thinking, ooh, that might be interesting. Patricia, wink. So I've given you quite a lot of links in this PowerPoint that you don't have to look at all. But I just thought if you'd like to know more or see where my quote came from, you can just click on it and go and read it. It's a mixture of scientific articles and more blog style articles. So the atopic conditions then. So if you look at the actual word, it means a genetic predisposition to develop an allergic reaction and produce elevated levels of IgE when exposed to an environmental allergen. And what it does, as I'm sure you're aware, IgE causes the body to release histamine when it comes into contact with that allergen. So that really, in a sense, when we're talking about atopic conditions, that's what it is. So that person has a genetic predisposition to developing this allergic reaction where they have higher levels of IgE, which leads to histamine release. So if you think, when I was reading here, it says a lot of the time, if kids have atopic dermatitis, there'd be a food allergy. Peanuts is a really common one, or eggs, but yet they might outgrow that food allergy, but the eczema stays and then they develop asthma. There seems to be, and I think that's the study I wrote down for you guys, there seems to be a real link. Kids that have dermatitis when they're small or babies and they react to food, so it could be dairy, eggs, peanuts, they then go on to develop asthma. And the mechanism is not at all understood. I read a couple of papers on it this morning and none of them seem to be able to agree on the actual mechanism. But I thought it's really nice to note that somewhere, if it's something you haven't come across yet, or if you've forgotten, in your triggers and your antecedents, when you're actually seeing a client and they have asthma, that you can think, well, and you can say to them, did you have dermatitis as a child or as a baby? And that'll be on their timeline. So you can be able to work back and see, yeah, they definitely have that genetic predisposition. So it's just something that's there. And then also there was more of that found that also non-IgE mediated food allergies are associated with asthma. So they mean IgG. And this to me, I thought was very interesting from a personal point of view, because I have asthma and I have an IgG reaction to dairy and a few other bits. But dairy is the main one. But I also would react to pollen, down feathers, dust mites, horses, even though I have horses and I'm an instructor, but anyway, and rabbits. And I was tested for those with the skin prick test when I was about 10. So I can see, it's really interesting. I can see that whole picture is there for me. And I would be very prone to dry skin as well. So when I read that, I thought interesting because I can see it. And again, I can see from clients, because I've had a few kids or friends' children that would have a dairy or an egg sensitivity, like might be called an allergy because they didn't test positive with the allergist, but they have eczema as babies in particular. Often they outgrow it when they start going onto solids and they come off formula. So around 1-ish, they often stop. But I would say 80% of those kids have asthma. The amount of my friends' children that have asthma now, and they're 7, 8, 9, and if I think back, they all, and it's true, they all reacted to one food in the top 6, very often eggs actually, and they all had dermatitis. So when I read this, the reason I put it in is just because I've seen this in clinical practice and I've seen it, word of mouth from my friends. So it's a good one for you to remember for the timeline. Just put that, you've had this already in there, so I don't need to go into it much, but just a little note at the end that Jess had put in bold already, that elevated IgA to a specific food suggests mucosal damage. So that's really important to remember. So if somebody's done an IgA test, now again, the most common tests available would be IgG, the ELISA test that you would get through, say, Larizian or York Laboratories. I'm actually not sure if they're IgG or IgA, but that's what it might suggest, that there's damage done to the mucosa and possibly loss of oral tolerance. So just if you are testing, or a lot of clients will come to you with a test result. I'm very skeptical of these tests, even though I did one myself, and I do think it's a good thing I did. But you will get people coming to you. I've had one client with rheumatoid arthritis and Sjögren's syndrome, actually, which you will see in the RA presentation. And she came with 2 different results for food allergens, she was told, done by hair analysis. One done by hair, one done with blood, and they had completely different results, like completely. So I'm very skeptical. I would be more inclined to do an elimination diet, which we'll do in a PNT. But it's just something to remember for you guys. And then we've just a little bit of extra stuff in there, because I thought it was really interesting that it's not just the immune dysregulation, that the skin barrier defects are really important to remember with dermatitis. The reason I focused on atopic dermatitis, which is your eczema, is that it comes before a lot of the other atopic conditions like asthma. So that's why I put it in there. And I thought it was really interesting that deficiency in certain components, so there's filigrein and there's a couple of others, they allow for more infections like Staphylococcus aureus. And Staph aureus is found in 90% of people with atopic dermatitis. Like, that's a staggering amount to me, 90% of people. I think that's a phenomenal amount of infections, and it's not something I was aware of. To me, Staph aureus would be an infection if there's something open on the skin, like my little girl had hand, foot and mouth when she was a toddler, and one of the sores got a staph infection, which is why she needed antibiotics. But that's the only thing I would have associated with it. I would not have thought that 90% of people with eczema have Staph aureus infections. Some of you might be aware of that, but I just thought it was a really interesting figure, which is why I stuck it in there. And then, yes, we know that it's immune We've talked about this already, but let's say with the atopic, so let's be more specific. So yes, it can be triggered by food sensitivity or food allergy, so your IgE, increasing your histamine. But what can happen is as well that that person has more bacterial infections, which we've just mentioned, your Staph aureus in particular, but also viral infections. And what can happen with them is that you can have in the skin, you can have T cell responses, predominantly Th2, which I'm sure you're aware of, that we would usually say that atopic conditions are Th2 dominant. What can happen though is that you start with a Th2 dominant, which shifts to a Th1 dominant. So kind of the old fashioned way of saying something is a Th1 driven condition and something is a Th2 driven isn't really correct anymore, because they jump from one to the other. And that's why the immune system is so complex. So this can start off Th2 dominant, but then change to Th1 dominant, which means you will have more pro-inflammatory cytokines. So what starts with a bacterial infection of the skin triggers your Th2 driven response, and then Th1 takes over with pro-inflammatory cytokines. Just an example there with your interleukins 4, for example, or 5, but also your TNF, which is your tumor necrosis factor. And then that will promote the IgE production and the systemic inflammatory. So it's like the outside happens first. So there's a reason why people are more susceptible to the Staph aureus infections. There are others, I'm just taking this one as an example, and they're lacking in a couple of different things, which is in your main, I think it was in Unit 8, in the Immune Imbalances PowerPoint. I think this is where I found some of this information. And it tells you which of the actual components that they're lacking in, but it means the skin is more prone. Remember, the skin is like your first line of defense from stuff not getting in. But in these people, the infections are getting in, triggers Th2. That then shifts to Th1, which releases your inflammatory cytokines, and then that triggers IgE response. So this is one of the ways that your atopic dermatitis can lead to that IgE-driven response and have some of the reactions that you would be associating with, redness, swelling, itching, all those things that can come with it. And I think that's interesting. You can then see why other conditions might develop if that person has constant infections on the outside of their skin, and you constantly have that production of IgE and that constant production of histamine. Those lovely slides that Patricia asked for and Sarah shared, they're so lovely. Like, I'm going to print them off myself, to be honest, and laminate them, stick them up on the wall. Just shows you the far-reaching effect of histamine in the body. But it can all start with a Staph aureus infection on the skin in a person who has these like predisposed lack of certain things they need to maintain skin integrity. So I hope that kind of gives you a little look at the atopic conditions.
Yeah, that's fantastic, Gwen. Thank you so much. It's really clear. Thank you.
Yay!
Hi, Gwen, it's Ulrika here.
Hi, Ulrika.
Could I just ask you, how do you know if a client has that, I can't pronounce it, but
the Staphylococcus aureus?
Yeah, if you're working with someone with that.
You don't know. You'd have to bring them and get them to get a swab.
Okay.
Taken, yeah. So again, this is a lot of the times. I laugh because I've done some of the training with the Institute of Functional Medicine, and all the doctors, or when they come over to lectures here, they all talk about testing, and they're like, test, don't guess. Do the organic acid test. You have to do a stool test. Well, you have to do a Dutch test. Yeah, and I'm sitting there going, how much money do these clients have? My clients save for 6 months to come and see me, If I suggest a test to them, they laugh me out the door. So a lot of it we have to guess, but you make an educated guess. So if this person has an atopic condition like eczema, they also have what you would think are like hay fever symptoms. Mm-hmm. The eyes, maybe mucus, a couple of other things, and you're thinking, yeah, that sounds like histamine driven. Well, then there's IgE that might be triggering that histamine. Well, why is there IgE? And it's like you work backwards. And then you say, have you ever been tested for Staph aureus? That's how I would usually do it. And then I say, well, the next time you go to your GP, and to be honest, I'm not even aware if the standard GP would just do a swab. I'm really lucky. My best friend's a doctor, so if I've ever needed swabs of things, I tend to just ask him. Like I'd mastitis, and he literally said, here's some swabs, you sample your milk and give me the tube, and he went and got them analysed for me. So I'm really lucky. But to me, that would be very simple. Like I worked in a lab where I audited the microbiology lab, and we had the virology lab, and it was just that tube with a swab and got cultured on agar. There was a couple of different things on the petri dishes and things, and it was literally just so let's observe the growth. And then there's different ways of identifying the different bacteria. So I would imagine that is exactly what is done for humans as it was for animals. But yeah, I'm not 100% sure. But I would just, in the back of my head, it's something I would consider. And a lot of people do know, or like that, they'll say, well, actually, yeah, I had an open sore, and it, like they might still have that infection because they might have gotten an antimicrobial cream on top. You know, so for my little girl, we were given antibiotics, which she just vomited up, so we stopped giving it. But it was a very holistic GP in Germany. She was homeopathist and an acupuncturist and a pediatrician. But she gave us an antiseptic wash instead and said, look, try that and just keep giving her, like we just kept giving her natural yogurt and all the more natural probiotics we could. And we gave her probiotic instead of the antibiotic, and it actually cleared up really nicely. So that's what I'm thinking. Some people might know. So like I know now she's had that once. So now that I've read that, I didn't know this until this morning. So that's now I'm like, I'd be asking every single client with dermatitis, I'd be asking them, have you been checked for? Because 90% of people with atopic dermatitis can have a Staph aureus infection.
And can that be linked then to if someone is not responding to the steroids or stuff like that that is given by a GP?
I would think, like, again, this isn't my area, and I only learned about this staph infection this morning. So to me, that makes total sense. And the problem is, of course, that we know that the steroid creams, I keep rubbing my arm. I don't even know if you can see it. They weaken the skin barrier. They thin the skin. So I'm like, oh my God, you're actually making it way worse because you're allowing that infection to get in and you're rubbing it in. So yeah, I actually think it would be a really nice thing if you have somebody with eczema to maybe go investigate how to get it tested, or if they can just do it through their own GP.
Just last question. If they do have that out of interest, how do they treat it then? Is that through antibiotics then, or how would it be treated?
I would say so. Like, I have to say for me, I'm not a huge fan of antibiotics for every willy-nilly, but I think if you have a diagnosed strain that you know that's there, yeah, I personally would absolutely. And then, of course, do all the bits that we as NTs know to support the body. Like, of course, you can try when people have bacterial overgrowth, you can do a lot of stuff naturally, like, you know, with cloves and oil, oregano oil and stuff. But I think when it's something like the skin and somebody's been on creams for years and they've got the asthma, and you can see with all the immune stuff that's going on, they're probably going to develop other conditions. You know, they probably have intestinal permeability. They're on the road for autoimmune disease. I would just nip that in the bud as quick as I could.
Yeah. Okay. Thank you.
Personally. Yeah. Based on something I learned this morning. Anyway, there is the article there that I took, because you can see it's a direct quotation. It's there if you want to read more. So you have this already, so I'm not going to go into it because I did mention most of this already. But again, I did think it was a really nice one, and it shows you kind of the histamine and what it does. Like a couple of years ago, histamine was the in word. It was replaced by SIBO. It'll be something else next year, I'm sure, in the functional medicine, naturopathic NT world. And it was all about antihistamine diet and low histamine diet and everything. But a lot of the time, I think that histamine is still a symptom. Now, that's my personal opinion. We look at the histamine instead of looking, well, what's actually causing the histamine, you know? So go back further. So that's where I think it's interesting. Well, if there's, you know, the Staph aureus maybe, so chat to the people. And thinking back over some of my clients, like I had one where clearly it was histamine that was the issue, and we managed to reduce symptoms by, I'd say 75%, 80%. Like he was so much better without changing his diet much at all. Really simple changes. We just took out the obvious histamine triggers. Like he came twice, and I would have loved to have kept working with him, especially now knowing more what I do. And I would be saying, well, why was there such an overreaction of histamine? You know, always keep digging deeper. Don't just take the main thing as the thing. So this was another one that somebody else asked as well. And this made me laugh because, to be honest, I looked at this and kind of went, what? But now I'm thinking, well, take it the way I did it. You know, IgE is your allergy, IgG or IgA is your sensitivity. You know, kind of work down it like that. So there are the slightly different ones. Now, the thing to remember with a lot of these conditions, a lot of them you're not going to be working directly with, like anaphylaxis. You're not going to be working with an anaphylaxis, or malaria. Do you know? Like they're not the kind of things you're going to be working with. You'll be looking at, let's say, the asthma or the eczema or hay fever. Again, with a drug allergy, what can you do? You know, if they're being put on a drug, that really is very much a doctor issue. I also think a lot of the autoimmune, the second category there, I don't think you'll be working with that because it's incompatible blood transfusions or it's a penicillin allergy. You know, so number 2 there, to me, yes, be aware that it can happen, but it's not something you're going to be addressing with the client. Number 3, that's where you're going to come into your own a little bit more, but say, for example, with rheumatoid arthritis, as an example. Like lupus, for example, is so poorly understood. There's so many different parts. Somebody's not going to come to you and say, treat my lupus. Because we don't treat anything. We look at underlying imbalances, you know? So don't get bogged down by this slide, because I think it's really beyond the remit of an NT. I would go back a step again and just go, well, is it IgE or is it IgG, IgM, or is it an intolerance? That's how I would look at it as a practitioner anyway, especially say for rheumatoid arthritis that we're going to look at now at the weekend. It's such a multifactorial condition that if you focused only on one thing, you get 2 reductions, so you forget about the others. Now, what it's talking about is your antigens. It's your, because of the citrullinated proteins, which we will go into detail on Sunday. So yes, it does feature there, but to me, I wouldn't think, I wouldn't put that with a food sensitivity, if that makes sense. Like I wouldn't class it as the same, really. It's one factor of a very complex condition. That's the way I would see it, you know. And you have your last one there as well, which again, like MS is a very complex condition, or like a chronic transplant rejection. You're not going to be working with that. You know, contact dermatitis, yes, that is something that you might get. You might have clients that react to bed sheets or certain types of fibers or whatever, and you might be the detective and you figure it out for them. But do you really need to be specific about the alternative name for it? No. So to me, this is a slide to have read and gone, oh yeah, there's different names for them here. Here are some of the conditions that are associated, and here's the immune cells. Happy days. Bye-bye. Tick. That's my personal opinion of it, because I think it's when you do the actual condition, that's when it'll make more sense. You know, like had I not read the rheumatoid arthritis, I would have gone, okay, now what exactly do they mean by the immune complexes and the, you know, whereas in having done that now, I'm like, oh yeah, I know what they mean, because I can use an example to explain it. So it's a bit like when we're talking about the eczema there, we're talking about the IgE and how it's been triggered. We've talked about it, you know, the viral or bacterial infection, then you have your Th2, Th1, cytokines, and then you have your IgE, you know, but that makes more sense now, I think, that first line, if you think about the example of a condition. So that's how I would very much feel about this. And I think this is the kind of slide where you could get bogged down and go and do a lot of research. Some of you might love this type of table, but just for those who found it a bit overwhelming, I just would honestly read it, leave it, and focus on the more important stuff, and focus on the stuff that you can do something about. So those of you who asked me to go through this, does that make sense?
Yes, thanks, Gwen. Yeah, thank you.
Don't get too bogged down.
Okay, all right.
Yeah, no, it's just too easy, I think, with the immune system sometimes. So I've given you, I only skimmed it really quickly, so I didn't read it all, but to me it looked like a really interesting paper, and it's from quite a few years ago. But because it was a review of systematic reviews, I thought this is a really decent paper to read, you know, because you're reviewing reviews, kind of. So there was a really good information in here, and it's all about the etiology of food allergy. So for anybody who's interested in this area, I have to say I'm going to download this and save it, because I see it a lot, and like that, having my own issues with it, I thought it was really good. But additional, don't go and read it if you don't have time. So let me just keep an eye on my watch. My gosh, it took a lot longer than I thought it would. So the immune overview, it's just a different slide, different diagram, because I found myself, when we were learning the immune system in college, I found that every time I heard it with a different diagram, different things clicked and made sense. So that's why I tried to do these for you. And for the lecture weekend PowerPoints, I've put in my own mind maps. So even though Lynn and Moira put together really good mind maps for RA and MECFS, I actually made my own in preparation for the lecture weekend, because I feel like if you see it in different colors, and even, sounds so silly, but if something isn't always in the top right, but suddenly it's in the bottom left, you're like, oh, you know? And sometimes you have to hear something 50 times before it clicks. So that's why this is just like, you know, this stuff, you know that the immune system splits. You know that there's B cells and T cells, right? That the T cells break into your CD8 and your CD4, or your helper cells, your T helper cells. Like, it's in some literature, you will see them as CD4, but most of the time it says T helper cells. That the main helper cells are T17, T1, TH1, and 2. You know that, but maybe this is a nice way of just going, oh yeah, I break it down. I always work well top-down approach. You'll see that next year in P&T. That's how my whole unit is structured, top-down, because I think it makes sense. And then we know more about TH1 and TH2, for example. TH17, I thought this was really interesting. So I only graduated, oh my God, how many years did I graduate ago? 5 years ago. And when we did the immune system, so 6-7 years ago, TH17 was a real, like, hypothesis. Like, even our textbook, the Biochemical Imbalances, which was 2010, I think it was written, like, said, like, oh, there's this new there was a half a page on it, I think, in the book on TH17. And when I dug a little bit further today, it's 15 years ago. It's only in 2005 that TH17 was actually officially acknowledged. So that's really new in scientific terms. So it's not quite fully understood yet. There's a lot more information now, which I thought was really amazing compared to 6 years ago. But just so you know, if you're reading stuff, you would probably read a lot more material on TH1 and TH2, because they're just more well known and have been studied a lot more. So some of the questions, so I think this was Camille, but it wasn't just you, a few people have mentioned cytokines. Now, I struggled a bit with this question because you yourself didn't know what you didn't understand. So I really wasn't sure. So I had put in all the cytokine slides, and I'm going, oh my gosh, there's a lot in there. So I added some of my own material in there. And then what I thought was, let me know at the end of it if it's clear, or maybe you then have a more specific questions about the cytokines. So that's what I'm hoping. So what I did was I put in more information in green. And basically the thing to remember as a practitioner is that when we have an imbalance in cytokines, that can lead to too much inflammation. And that can then lead to attacking a friend, right? Which could be like an allergy or a sensitivity. So something you shouldn't be reacting to, like dairy, for example, or you're reacting to yourself, which is autoimmunity. So we want a balance of our cells. Giving you a really quick, again, we've mentioned TH1, TH2, TH17, so I don't need to go into them in a lot of detail. So a couple of examples I gave was if TH1 is out of balance or out of whack, as we would say in Ireland. Examples are type 1 diabetes, Hashimoto's, and MS. So they're kind of the big conditions. TH2 then would be classical, like we said, the allergies, the atopic conditions that we've mentioned already, but also some things like some autoimmune conditions or lupus as an example. Something that attacks multiple tissues is often TH2. And then Th17, I liked this wording, so I kept it. It can play both sides of the field. I like that. I thought so. This to me suddenly made me really kind of embed Th17. It's like you have a blue team and a yellow team playing against each other, right? And you have Th1 and you have Th2s, one color each. Let's say that there's a red card against somebody on the blue team. Well, then the yellow team suddenly has the power. So that could be like, and they're going to dominate, aren't they? Especially, let's say that if it's a soccer match and there's only 11 players, and if you've ever seen a match where there's 2 red cards or 2 yellows and a red, and 2 players have been sent off, and you have 11-9, well, that team of 11, even if they're not a good team, very often dominate. So I thought that was quite nice to remember. Well, if that's Th1, if the yellow is Th1, then you get a Th1 more dominant condition, for example, Hashimoto's. If you have the other way around, the blue team have a full team, but the yellow team have people sent off, well, they're going to dominate, and then that's Th2. Your Th17 then is a player that is wearing both yellow and blue. And if the blue are down, he puts on a blue jersey. And if the yellow's down, she puts on a yellow shirt, for example. So it can go both ways. So the thing that, and this is what I've just said, we're not fully sure exactly what Th17 does fully, okay? And it can jump between the two. If there's too much Th17, it seems to mirror a Th1 excess. That's the one thing that does appear to be fairly well acknowledged. An example can be chronic Lyme. So chronic Lyme disease, which is very poorly understood, especially in Ireland, and it can take a long time to get diagnosed. If you're in Germany, it's much quicker because it's more common over there. Actually, I say more common, maybe not, it's just more diagnosed over there. And even if somebody does a test here, they send it to the German lab. You know, so there's no Irish lab that I'm aware of that actually tests for Lyme disease, but some more forward-thinking doctors here sample the client and send it over to a lab in Germany. It's one main lab, as far as I'm aware. So, for example, chronic Lyme disease is a combination of Th1 and Th17 excess. And then just a note, which I think is really important, is that Th2 domination is normal in pregnancy, and it's to avoid rejection of the fetus. So this is what will prevent a miscarriage. Because of course, to the body, there's suddenly something growing in there that shouldn't be growing in there as far as the immune system is concerned. And of course, the uterus is like, well, hey, I'm finally doing what I'm supposed to do. But the immune system is kind of going, eject, eject, get rid of it. So by shifting to Th2 dominance, we don't. And the fetus can grow in utero. So I think that's an interesting one. But of course, if you're Th2 dominant then for the duration of your pregnancy, some allergies get worse. And you hear that with people all the time that never had hay fever, and suddenly when they're pregnant, hay fever was out of control. And they're sneezing and, you know, they're doing loads of other stuff. Whereas other things that are more Th1 dominant, they've got like no symptoms, you know? So for example, autoimmune conditions actually ease up when you're pregnant, and it's because suddenly, instead of being Th1 driven, the body's Th2, which means the autoimmune conditions calm right down. So that's just kind of one of those interesting things, like the Hashimoto's, for example. I know, Darren, you asked a question there about the thyroid conditions, pregnancy and after. So I'll go through that Saturday morning, but this is one of the things that's involved. So that's why I put it in. I thought it'd be interesting. And just, I think this kind of makes sense, that dominance of one suppresses the other one. Think of your football teams or your rugby teams or whichever the case is. If you have more players than one than the other, they're going to dominate. And it's going to be harder for the others to fight back. So I just thought that wasn't specifically in the summary PowerPoint, but sometimes I know for myself, it's good to get a reminder of the 3 different types. Balance is key, I've already mentioned that. And it's not just the T cells, but also the cytokines. We need a balance because we need both. And the example I gave there is the prostaglandins. So some of the more inflammatory prostaglandins, we actually need to induce labor. I mean, women are given prostaglandins to start labor. That is what an induction is. When you hear about a gel, they're prostaglandins, right? So we do need them. They help the contractions. So every woman who's ever given birth, not, you know, without a C-section or prior to the emergency C-section, you want the uterus to work and have the contractions. So prostaglandins are not always bad. Whereas we, I think, very often get stuck in the whole, all cytokines are bad, and they're not. We need them all. They have a job. We need them in balance. And always think back to your basic biochemistry of the body. The body wants to remain in homeostasis. It wants to remain in balance. So it is like that for hormones. It's like that for the pH of the blood, for the nutrient in the blood, but it's also like that for the immune system, for your T helper cells, for your cytokines. Body wants to be in balance. So that's why I thought this was a really nice little diagram that I put in today. And it just gives you, so you have your antigen presenting cells in the middle, and then it just gives you an example of all the different cytokines that there might be. So some would be anti-inflammatory, some are pro-inflammatory. You can see how many more pro-inflammatory ones there are, can't you? The interleukin and your tumor necrosis factor and your interleukins. But if they are dominant, well, then they're going to be the team with the most amount of players, and they're going to basically score the goals and decide what happens in the body. So it's you kind of want to shift it into a more even balance. Of course, acute pro-inflammatory cytokine dominance is fine when we have acute inflammation. If somebody damages their ankle, let's say they twist their ankle, right, and if there was no inflammation there, they wouldn't know. They would have no pain, they would have no swelling, there'd be no redness, and there would be no heat, right? So they wouldn't know that they need to put that leg up, elevate it, rest it, ice it, you know, rice, if you've done first aid. But that's why we have inflammation there, because it does all those things. And I'm sure you know this now. Why is it red? Why is it hot? You know, it's basically your paramedics are rushing in. The immune system is rushing in, and that sudden increase of blood flow does all those wonderful things in the healing. So we do need it. It's when it's chronic. So I think that's the most important thing to remember with cytokines, is then we have a chronic pro-inflammatory cytokine dominance. That's when we have the problem, because then we get chronic systemic inflammation. And systemic meaning it affects the whole body and not just one area. It goes everywhere in the body. Some inflammation is fine, but when it's constant, that's not good. So then these are the slides that you already have, which is why they're not in green. The influence of stress on the immune system is really, really important. So the thing with, say, cortisol, I know students always get confused when I say that really cortisol is anti-inflammatory, but when it's consistently being pumped out, it becomes inflammatory. But what you can see, what it does is at the beginning, it inhibits Th1 reactions, but then on a long-term basis, it stimulates Th2. So it contributes to that Th2. So not only does it stop Th1, but then it promotes Th2 mediated reactions. So if you think back to some of the conditions we were talking about, like how many people do you know with asthma or with eczema that would say stress makes it worse? Like, hand up myself, and it's cortisol doing that, you know, because it is stimulating that Th2 reaction. So there's one of the things that you do need to know. And then the other thing as well, that corticosteroid medication can do the same. And this is where I have a real problem with people being prescribed steroids for eczema, for asthma. It's with the asthma inhalers. They've changed a lot now, thank God. But I know back in the day, it was a case of, well, you can't take that asthma inhaler for too long because it's got steroids in it, da 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 da. There's this whole thing. And now you know what you know, having studied this. You can see why. Well, I can anyway, because if you're putting something into the body to skew towards Th2, you're actually in the long run not helping that condition at all. But it's something worth noting for your case studies in assessments. Okay, so it's just a little heads up. Here's one of my famous winks. Remember corticosteroid medication use for the future. Then we have, for example, you have your transforming growth factor, TGF-beta. So that's one of the things that regulates Th1 and Th2. So that's one of the things that is good to help bring us back into balance. And then we have just Th17 is complex. I've said that already. I think I've mentioned most of this actually. Yeah, but it is interesting actually that IL-10 can restrain Th17. So this is I think the difficult bit for me, and I'm sure for you guys as well, is how they all have an impact on each other. All the individual cytokines, and like Jess has put in tons of slides and diagrams that she's put together herself of how all the arrows, how they all affect each other. And I feel a bit like about the Krebs cycle or the hormones and all those webs in the functional medicine models. Just start somewhere, you know. Don't think, oh well, now I need to look at IL-10 and Th17 and Th2 and no, just stop and just zone out. Look at the condition. Well, where can I start? Because the body is really, really smart, and the body wants to be in balance. It wants to be in homeostasis. If you can just, it's like throwing the body a lifeline. If you can just intervene somewhere. So if all you can do as an NLC practitioner, so some of you I'm hoping are practicing, well, I know Jill is. So if you just go in with stress management and you lower cortisol, you're going to help not put somebody in that Th2 dominance. Well, that's going to have a trickle down effect, isn't it, on the rest of the immune system? But all you've actually done is got them to go and practice maybe Wim Hof breathing, go golfing. So I know Jill likes to golf. You know, just you're doing all these lovely things for somebody without actually going in and looking at the specific prostaglandins, for example, or the interleukins that are involved. So yes, you need to understand it, but don't get too bogged down by specific ones. You'll see the same ones come up time and time again for the conditions that you will see with your own clients, you know. So for me, because it's hormones, I see PGE2. That's the main one when it comes to estrogen, interleukin 6 a little bit, and then insulin-like growth factor. Like there's a couple that just keep coming up for the conditions that I see in my clinic, and you will be the same. And they're the ones you'll get to know. You know, so yes, it's good to know that Th17 can be restrained by IL-10. It can be induced by TGF-beta and IL-6. You know, like this is all really interesting stuff, which is why it's in there. But just remember, it's not the most vital bit for you to remember all those diagrams of how each one interacts with each other. Basically, what we want is we don't want dominance of anti-inflammatory or inflammatory. We want a balance. Same with Th1 and Th2 and Th17. We want a balance of them. If there is an acute situation, bacterial infection, viral infection, physical, like a fracture or maybe another toxin, like fluoride, for example, then of course you want the body to react, but it should always return back to normal. This is where you're thinking always the paramedics need to come in, the parasympathetic. That's how I always remember it. It can flare up like the stress response. That's what keeps us safe. You know, body is really smart, but that state shouldn't be there all the time. It should calm down. And it's the same thing with cytokines. They need to come back down to normal again. Like if you look at Th17, poorly understood, and then there's loads of different ones that induce it or don't. So for example, if the Th17 is induced by interleukin 23, it's much more pro-inflammatory than if it's induced by some of the other, oh my God, what's the word I'm looking for? Some of the other cytokines. You're not going to be doing that level of detail with the client. Okay, you're not going to say, okay, I think your Th17 is more pathogenic or more inflammatory because it was induced by interleukin 23. Like, how can you possibly know? So understand that there's complexities and intricacies in the development and that they all link to each other. As long as you say, well, how am I going to, and you're going to learn this next year, so you don't need to know it now, how can I help balance my so my T helper cells? That's the important bit. Okay, so please don't get bogged down because there's a lot of slides in the summary PowerPoint and in Unit 8 that I think are just amazing to teach you about the immune system, but you don't need them to become practitioners.
Gwen?
Yes.
Sorry. Just to say, today I was working and I actually got to use the diagram of the clinical imbalances, the mind map of the interrelationships between the clinical imbalances with the different categories of imbalances. So I have a client who's come to me now for about 3 weeks, and she has had stage 1 breast cancer and she had a mastectomy, but her weight is really up and she has been told to, you know, bring the weight into online, and she had all the symptoms going on, the weight gain, the thyroid, the fibroid. She'd had everything, and the constipation. And I pulled out the diagram, and I was going, God, will I show it to her? Won't I show it to her? And I did. And she just said it was just so clear. Not that I could, you know, explain, but I was able to show all the links between everything. And she actually found it, you know, so clear. And even though obviously I'm not going into any of that kind of detail really, but and the estrogen dominance and everything, but it was a great example today to see how you could just show that, and it actually was really clear.
Absolutely. You know, clients love it. It's the amount of clients I've had that will say, oh my God, you've just connected the dots. And it's nurses, biochemists, like these are scientists, people who've studied science, who know, like I used to do mini consultations in the shop that I was in. So I would see 4 or 5 people within space of 2 hours, say. And a lot of the time it was just doing exactly what you just did. I just showed them the link and basically said, look, it doesn't really matter where. Like the amount of people that came in with Hashimoto's, really, oh my gosh, so many people with hypothyroidism, and 2 of them were midwives and 1 was a nurse. So highly educated, understood science, had medical training, and I said stuff to them. I just literally said, well, do you do this? Do you have this? Do you have that? Do you have that? And they were like, yeah. And I said, well, that's all thyroid. And they just mind blown. So, but again, you're even by showing the interlinking of the imbalances, you're taking a step back though from the finer detail. And I think that's important to remember, that speaks to clients really well. If you chat to a client about TH17 being induced by IL-23, like, no. Do you really think? No. But if you can say in your immune system, you have lots of different cells that respond to different things. Some of them produce these things called cytokines, or you can call them chemokines, or what's the other word somebody said? Inflammatory chemicals, you know, keeping it simpler. And then you can say, well, there's a couple of different types. And in certain conditions like asthma, one of them is more dominant than in others, which is why maybe when you were pregnant, you had an alleviation of your other symptoms, So you're explaining it, but you're explaining it at a slightly higher level. Now you understand the bottom level science, you know, all the detail, but take it out. And same when you're addressing something, you're not going to look at IL-23 inducing TH17. That's too much. You're looking at the overall imbalance of cytokines and what can you do about it. But I'm delighted you got to use it because it's so powerful with clients.
Yeah, it was. It was really great. And as I say, I wouldn't have been going into any TH1, TH2 or anything like that. But it was really, it just made it so clear, and she got it like straight away. So I was kind of going, oh, that's great now.
Yeah.
Pretty chuffed to be able to use it. But anyway, so thanks for that.
Yeah, the visuals are brilliant anyway. And mind maps. I'm a huge believer in mind maps. Anyway, so yeah, if the one thing now I will say, if you have somebody with a condition where, you know, like I said, with the PG2 or the IL-6, when you know there's specific cytokines involved, then yes, do look at them. And then maybe there's a specific SNP that shows they're upregulated for something. Or the specific foods you might be able to remove or put in. You know, like for example, with the eicosanoids, which we'll talk about in a little bit, and your omegas, that's different. But don't think you need to know them all, really. I'm just trying to take kind of the stress out of the cytokines. I'm hoping they are really important. They are a massive mediator for nearly every chronic condition that you see. So you will be looking at them all the time. Like every matrix I've ever done, cytokines have been there, you know, because there's some reason why they might be imbalanced, but there's loads you can do about it. So I think that's really important. Another lovely diagram that you have already, and has your PAMPs and DAMPs up there, which we will talk about. And what I think was interesting at the NTY AGM, we had Ben Brown speak to us, who, Ben is just everywhere. He's phenomenal. He's the editor of magazines, and he publishes quite a lot of work in conjunction with one of our own in Ireland as well, Kira. They did one on supplement use in pregnancy that was published this year, a couple of months ago, I think maybe just before lockdown. I'm trying to remember. But yeah, he's always great, and he talked about inflammation. So he did like an hour presentation on the immune system and inflammation, and he had been booked to do that before COVID-19 ever came to Ireland. But it was very interesting because it was very practical advice. And like, this is a man who's had years of experience, who trains practitioners, who lectures other practitioners, who's a lecturer himself, you know, like vast amount of knowledge. And he kept it so, like, he was talking about anti-inflammatory foods, but not one type of diet. And then he just picked a couple of different foods and I think 6 specific nutrients. And he said, and that's all you need, because you're giving the body the tools for the cytokines to come down. And that's kind of in my head, because that's more practical approach rather than thinking I need to know all the very specifics in here. If you are a person who needs to know the specifics, they're all there. I mean, the Unit 8 PowerPoints are so thorough. But something like this might even do you. You know, you can follow the little lines around, which I think is really handy. And you have your mediators, you have your triggers. So if you're filling in a matrix for a case study and you suspect that there's inflammation, well, this is the slide for you, you know, because in your little box for mediators, well, look no further than this list. They're all here. What are the possible triggers? They're all here, you know. So if you have a person with eczema, atopic dermatitis, well, you might say, trigger, could it be a Staph aureus infection? That's your trigger. So like Ulrika said, would you get a client to test? Let's say you got to test and they took antibiotic. Well, then you could remove that trigger, you know? So that's one of the things. I think this is a really lovely, lovely slide. It's another one I'm going to print off for myself and keep it in my folder. I think this is a really good one. And it gives you your conditions as well. So as you know, we'll talk about RA at the weekend. We've talked a little bit about Hashimoto's as well. And then we'll look at some of these next year as well. Endometriosis, for example, we cover in Unit 8. And we've talked about eczema a good bit already today. So I think that's a really handy one. Yeah, we don't need to talk about them much more. So these are the slides that you already had. And to be honest, I've left them in here, but I really feel if you kind of know what the stuff that I covered there in green and take into consideration what I said about not getting too bogged into all the links, like, you know, slightly later on, there's an even bigger one, then you're fine. Like, these are great to have and to understand them, to know all the different things that can happen, you know. So like your TGF beta, that it can have an impact on Th1 and Th2 balance. Remember we said that about 2 slides ago. So it is important, but again, it's not vital. And like that, look, Th17, they mentioned TGF beta and IL-6, but I've already mentioned that IL-23 can have an impact as well. So it just gets very minute detail. This is kind of top level stuff. I think this will be enough really to remember that these can have an impact on each other and how. So like how Th1 can have an impact on Th2, interferon alpha, and then interleukin 10 going the other way, you know. I think that, to be honest, I think this slide is kind of the enough detail that you need to know. This one makes it bigger, right? So you're adding on all the different cells. We've talked about histamine release already. So histamine release can trigger interleukin 4, which then activates T helper cells 2, which can trigger, if you look down the bottom, it's hard to see, eosinophils, or it can release IL-4, 5, and 6, which can then lead to the production of immunoglobulins. You know, so these are really handy, and look at them, but just, I think some people might get a bit bogged down by the diagrams, so don't panic, you know, use a couple of different ones. Like even if you look at the top there, we talked about TGF beta and IL-6 stimulating Th17, but here there's a couple more, and IL-23 is mentioned as well. So, you know, just trying to make sure you don't get too panicked by it all, because I think actually addressing immune imbalances is not that difficult. This looks really challenging, but then actually doing something about it isn't. I think that's the, I'd love you to take that away, because you've met the ACs for this, you know, it's done. So don't panic about it now, because there's stuff you can do about it really easily. Things like olive oil and fish oil can have a huge impact. So don't panic. So then, is there anybody who was confused about cytokines? Do you feel a little bit better, or are you more confused?
Yes, thank you very much. I will review it in tomorrow as a whole, and then I will come back if something is not clear. But thank you.
You're welcome. Okay, so then we have the difference between malt and galt. So malt being your mucosal associated lymphoid tissue. And it's basically your lymph cells that are concentrated in the mucosal tissue. Simple enough, right? But what it does is it initiates immune responses to specific antigens that are encountered along all mucosal surfaces. So think anywhere where there's a mucosa or a mucosal lining in the body, if there's a specific antigen that is picked up, let's say, by that mucosa, it's the lymph that responds and stimulates production of IgA and IgG. That's what it does. In the most simplistic, I try to keep this really simple, because funnily enough, when you go researching this, there's not a huge amount of information on these. Like, they're so important and everybody talks about them. But then when you actually go and read, it's really kind of top level stuff, I found. Like, I kept looking for mechanisms or underlying actions, but I suppose you have that in other places. You know how the B cells are, the involvement of the B cells and then the immunoglobulins. Really what you need to know is that it's the lymph sitting, let's say, inside the mucosal surfaces, and they are what respond to the antigen, and they then start the immune response. It's like an interface. That's the way, to me, that's how I remember it. I can't remember what lecturer said this to us. I remember they said that. They were like, the malt, like the galt is part of the malt, but like they said, the malt is like your interface between, it's like almost like the outside and the immune system, and it's what says react. I've recognized this, do something about it, and then the immune system takes over. So it's really, really important. Or think of it maybe, I don't know, I'm trying to think of something like even a sieve. You see, it's not really, it doesn't really filter stuff. Interface is the word that I'm thinking of. It's like a line of code that recognizes something. You know, it's like programmed to recognize every 0101, and if it finds that, then it triggers the release, the production of IgA and IgG. I don't know if that makes sense. I hope it does. But the malt then basically, the galt then, which is the gut-associated lymphoid tissue, is a part of malt. So there's loads of different types of it, actually. Like there's salt and there's loads of different ones. But it's specific to the digestive system. So others would say it's the all the intestine, basically the digestive system, you know, the gut associated. And the example is the Peyer's patches. And it's like a real concentrated lymphoid tissue sitting in the gut. But again, it's in all the mucosal linings. So it makes sense that it's in the digestive tract because you have a mucosal lining. And then I thought this one was a nice one in this paper that I referenced as well. It says the galt is the intestinal frontier of the systemic immune response. So it's like your front line, you know, like your boundary that then triggers a response. So you could even say maybe it's like a scout, you know, in an army that scouts ahead and then recognizes the enemy and rushes back and says, right, fall into formation. That's your immune system. I'm trying to give you loads of metaphors. I don't know if they're working. And then another function here is storage of immune cells, such as B and T cells. So that's another function of the galt. Everybody agrees that it's really important. If you read the papers, like they're saying, it's an essential part of the immune system. But really, to me, I kind of think of it, it's like what recognizes it, it's sitting there, and then it's like, okay, it's like B cells, stat, off you go. You do your job. And then the immune system is where we look really. So it's like this interface between the digestive tract and the immune system. How does it work together? It's like the galt. So I'm hoping that it's helped a little bit, because it's definitely not something I hugely know about. Like I said, I went and read this morning. And this is pretty much what I got from reading. I think I read 4 or 5 different things, and this is what they condensed it down to. So does that help a little bit? I can't remember who asked. I'm sorry, there were so many questions.
Yeah, Zita, I asked you. Thank you, and it's very clear now. So
good. Yeah, no, just because, like I said, I couldn't find a huge amount on it, which I thought was really interesting, actually, because it's something that's thrown around all the time when people talk about the immune system. You hear about the galt all the time, and then I was like, why is there not much information? So it's something I probably will go and read up between now and the weekend again. But anyway, I'm glad it helped. And there is more to read. There's one PubMed article there. And just if I ever put in articles, if it's abstract only, I'll always say it's abstract only. Otherwise, it's always full articles for me. So then a couple of people were asking about icosanoid balance and the arachidonic acid cascade. So again, I think sometimes we overcomplicate this. The detoxification of estrogen I will do on Saturday morning because I'll have more time and I want to use it to illustrate phase 1 and phase 2. Now, the question, I think it was Zita, wasn't it? About the EPA.
Yes, that was.
Yeah. As far as I'm aware, it is PG3, not PG1. So, but again, I can't ask Jess. So it's a bit of a problem because I went and did loads of reading on it. I am going to dig a little deeper. I wonder, is it just a typo? Because in the PowerPoint, one slide says PG3 and one slide says PG1. Everything that I've known about and have lectured about when I did macronutrients, it's PG3. And I checked quite a lot of different places today and they all said PG3. So I will confirm this, but at the moment, I did find one place that said it can lead to both PG3 and PG1. And then they're saying that this particular source, which I don't really trust because it was saying that PG1 is inflammatory. So I was a bit questioning that. So to me, I would just go with EPA PG3, but I will try and get you a definitive answer for the weekend. Might even be after, because I'm actually just going to email Jess and ask her, to be honest. Because it's highly unlikely that she made a mistake. You know, I would own it. I'd be like, oh yeah, that was me, that was a typo, but highly unlikely with that particular unit leader. So I'll double check it for you and I will confirm it to you. But in your own head, I would go EPA PG3. Like I do know that some people say you can get an inflammatory from EPA. I'm aware of that. I've read that before. But it wouldn't be the main thing to focus on. All right. Okay. So
Okay, thanks.
Sorry, I didn't fully answer that question. So here's one of the, and this is the one that I mentioned, that down the bottom has your PG3 and then on the left has PG1, and again it says PG1 is anti-inflammatory, so that's why that one source I'm not quite happy about. So this is one of the cascades that you had already. I think it was your main immune PowerPoint. So it has your omega-6 on the left and your omega-3 on the right. There's a couple of things that are important to remember, which is your enzyme, the delta-6 desaturase enzyme. And the reason that's important is that it can do both, right? But it needs the cofactors to work properly. So the cofactors is magnesium, zinc, B3, B6, and C. Now, having done other units, can you just think, like, if somebody's low in these, what else isn't going to work properly? Their stress response, because you need magnesium and you need vitamin C for the adrenals to work. You need magnesium and B3 and B6, especially B3, because it's needed to make NAD. You need these for the mitochondria to make ATP. Where do we need zinc? We need zinc for the thyroid, right? We need zinc for sperm health. Like there's so many reasons those specific nutrients are needed that if that person's intake is low, well then they're not going to be doing this properly either. So that's why I think it's really good to have this in here. And this enzyme really is important, the 6 and the 5, because they can shunt them one way or the other, depending on what you've got in there. So if the enzyme is there, this is something I was lecturing for the macronutrients a while ago, said to the students, it's like the enzyme is sitting there and it doesn't care whether it acts on ALA or LA. It's like, whatever, I'll work on it. It's like an equal opportunities employer, right? So if you're putting in loads of sunflower oil and soy oil and processed food like crisps, popcorn, pastries, all the rest of it, and you're not eating your walnuts, dark leafy greens, fish, seaweed, all those lovely omega-3 sources, well then you're going to have things happening down on the left. You're going to end up more with inflammatory cytokines. And that's not because of the enzyme, it's because of the substrate. So I think that's really important. Don't get too bogged down again by the individual little, the LA to the GLA to the DGLA. I don't know that. You know, I know LA starts and ALA starts, and this is my end. That's what I know. And I know that it's the desaturase enzymes that do it. But what's important is make sure it has the raw material to actually do its job. It's almost like going to the hairdresser and saying, I want you to color my hair. And the hairdresser is going, well, I have the color, but you've shaved your head, so I can't color your hair. It's a bit like that. Then you can, of course, go straight in. This is, if you think the primrose, evening primrose oil and the starflower oil, I think they're really important to remember, because a lot of women take these for PMS. And also I've seen borage oil being advertised to menopause as well, really, really often. And GLA is absolutely needed. We really do need it. And I think especially if women are not taking in the vegetable oils, the soy, the processed foods, you know, if somebody has a really unprocessed whole foods diet with oily fish, with green leafy veg, they may actually not have enough omega-6. That does happen. Now, it's rare, but it does happen. So then if they're taking evening primrose oil, that's probably brilliant, because they're taking the GLA, leaving the delta-6 desaturase to work on the ALA, because the GLA is already there. Then your elongase does both, breaks them down, right? But those middle steps there, the DGLA and the precursor to EPA, I'm not even going to pronounce that. To be honest, I wouldn't worry about them, right? They're not going to come up. I have never once used either of those terms ever in 5 years of practicing. I work the top ones. I do talk about GLA because of the starflower oil and the evening primrose oil, but then really it's the arachidonic acid is really important, and your EPA and your DHA are really important. Now, your meat, dairy, and eggs can provide arachidonic acid. What is really important to note is that a lot of research this year is coming out basically saying that none of them are as inflammatory as previously thought. So I really do think this is important to remember. And again, it's a balance, right? If you have the EPA intake and then you have your meat, dairy, and eggs as well, let's say you're an omnivore, well, then that arachidonic acid isn't necessarily bad, because we do need leukotrienes and we do need our prostaglandin series 2, you know? So a little bit of it is not bad. So you can't go out there, and some practitioners do this, unfortunately, and I really don't want our graduates to do it, is to go out and say all meat, dairy, and eggs is inflammatory. Because it's not true. There's more foods in there. Like you'll see with ME/CFS, that meat is an excellent source of carnitine, which we need to make energy. So one of the best things for somebody with chronic fatigue can actually be good quality meat. So if you're going in there saying, well, it's all inflammatory, well, it's not necessarily true. Dairy that has been fermented has actually been shown to be anti-inflammatory in a really, really big review. I'm trying to remember how many studies they reviewed. I think 17. Or was it even more? Really interesting that fermented dairy is anti-inflammatory, whereas we're so geared to always say it's all inflammatory. And this is from a person who is dairy-free herself, you know? So I'm not saying this so that you all drink dairy. Just be mindful that it's not just one or the other, and that a little bit of arachidonic acid is good. We need it. So omega-6s are needed, and so is arachidonic acid. If somebody doesn't eat meat, dairy, and eggs, and they're on a really unprocessed diet and they're not taking soy oils or sunflower oils, well, then you do probably need to go in with something else like the evening primrose oil to make sure they have enough omega-6. It is possible for people to take it too far, to have too little omega-6. Omega-3 then we know is really important. Thing about omega-3, to be really honest, is just to remember that if you're relying on EPA and DHA from vegetarian or vegan sources, you need to up your intake hugely. The conversion of ALA to EPA is as low as 0.8%. The max figure I've read is 21% in women, and in men I think it's 8%. So if you're eating walnuts with, let's just say 1 gram of ALA in the walnuts, well, you might only be converting 20% of that. So you're getting 0.2 grams of ALA. Well, that ALA, 0.2 grams needs to be converted to stearinic acid, the next one down, and then EPA, and then it needs to be converted to DHA. Whereas if you just ate a piece of fish, you'd be taking the EPA as it is, and you only have one more conversion. So that's just something I really want to stress that practitioners understand. Absolutely okay if somebody's only getting the ALA sources because they don't want to eat the fish. Absolutely fine. Just be aware that it's not necessarily good. It's a good source of omega-3, but omega-3 is not just, doesn't mean EPA, it means ALA, and it has to be converted. If that person then is deficient in magnesium, zinc, B vitamins, and vitamin C, and biotin, well, that conversion isn't going to happen. So it's just really important, especially in men. For male clients, I'm really very strict about recommending fish oil supplement. If they won't eat fish, I'm quite firm. Now there's much more better supplements coming out, you know, vegan supplements with high EPA levels. So it's like they've done the extraction and the conversion for you, but it is something to just bear in mind with clients, that when they're saying, you know, I don't want to eat fish, which is absolutely, I totally understand that. I don't want to take a fish oil. I'm eating a handful of walnuts every day. And then they have signs and symptoms of inflammation. Well, this is what might be happening. They're just not converting it. And like the science really does agree in men, like most places are saying 5% maximum conversion. 8% was one article that I read. So it's a very small conversion down. So this to me is the diagram. I've left out, there's loads of others in there, but I think if you understand this one, this is a really good start. This is one of the ones that was in there from Unit 8. It's just, to be honest, it's exactly the same thing. It's just done in a table format, so I'm not going to go through it. This breaks it down a little bit more, looking at your actual production, the enzymes there. So the enzymes that you'll be familiar with are the lipoxygenases and your cyclooxygenases, basically your COX, and some of the others will be called LOX as well. But the COX enzymes, COX-1 and 2, are really the important ones because we know of them as medications. You know, COX-1 and COX-2 inhibitors. So I'm trying to remember which one, Darren, you will be able to correct me. Is it aspirin? I think is one of them. Meant to look that up before today and I forgot.
Yeah, aspirin, and diclofenac, those kind of ones.
Yeah, so that's the enzyme that they work on. So now we know why, because if you're thinking, well, a lot of the signs and symptoms of inflammation, if you can block the enzyme that is producing that cytokine, well, then you're not going to have that sign or symptom. And then they just have the examples of what they do. So for example, PG2, which is produced from your omega-6, if you think back down your left-hand side, so it increases the rush of white blood cells into the damaged area, which is a good thing. We want that. More histamine, upregulates blood clotting. I mean, that's very important if you have your leg sliced open, right? We want clotting. But then it also increases uterine contractions. Again, that is something we want if we're in labor. If we're not in labor, we don't want that. So that's just an example, and you might get more and more familiar with them, like the leukotrienes, your thromboxanes. They're all different cytokines. And like I said, I think it's better to learn the condition and the cytokines that are associated with that condition, rather than focusing so much on the cytokines, because I think to me then it's just a random scientific term. Whereas if you can learn, okay, well, with this condition, these are the main cytokines that are involved, you'll remember that. That'll stick, you know, because you can make it practical about that condition. You know what? Very similar thing, really. Here's just going into the fact that you phospholipase A2. What does that do? Or why does it get activated? Sorry, it's your histamine. Activates this, that can convert to arachidonic acid, and then you have all the conversions that we had already. What happens? Well, we've talked about that, your uterine contractions, increased white blood cells. So these are all really just chunking down. All the diagrams have chunked it down a lot. Arachidonic acid cascade is here. We've already said that it gets converted down into your inflammatory cytokines like your prostaglandin series 2, thromboxanes, and leukotrienes. And then talked about the medication that blocks the action of COX-1 and COX-2 enzymes. So that reduces the production of pro-inflammatory eicosanoids. So sometimes that's a good thing, and sometimes it's not. You know, I always think, like, why is there pain? Like, there's a reason why there's pain, and the reason is there so we don't move that body part, or because there's inflammation, and why, then you look deeper. But absolutely, sometimes you have to take something to stop it, you know. But I think it's just remembering But somebody who's taking a lot of medication, I always ask, why are they taking? Well, it's for pain. So in my head, I'm going, okay, well, if there's pain, and they'll say, oh, it's swollen and there's pain. So in my head, I'm going, okay, inflammation. Well, there's pro-inflammatory, so that's arachidonic acid. And then it's almost like I think back up. The symptom is the pain, taking the painkiller to stop that symptom. Well, what's it doing? Go back up. Well, okay, it's prostaglandin 2, let's say. I'm going to work back up. Okay, well, there's arachidonic acid. Well, what has stimulated the arachidonic acid? Histamine. Well, why is histamine being activated? Histamine, IgE. Oh my gosh, why is IgE there? Maybe it's Th2. And it's like you're climbing back up the ladder then, sometimes. So I find that with this cascade, that seems to work really well for me as I work from the bottom up. Same with I want EPA. How do I get EPA? Oh, well, I need my delta desaturases, my 5 and my 6, and I need these food sources to make sure that there's a substrate. Let's say I want pro-inflammatory, I want the uterus contracting because it's labor. Well, I mean, you're not going to induce necessarily the contractions by drinking sunflower oil, but it's just an example to give you. So there's your arachidonic acid cascade and your eicosanoids. Again, look, it's the same thing over and over and over. And then it just tells you some of the meds that we mentioned already, like your non-steroidals. The example I gave you was the aspirin, the one we always learned when we did pharmacology. So I'm glad I remembered that right. So that was one of the things. I'm just very aware of the time running out. So I'm hoping that helped, because I know a few people were worried or concerned about the eicosanoids. So what I'll do is I'll fly through the next few bits, and if you just, at the end, you can let me know if you're not quite clear, or like I said, just put it on the forum. The DAMPs and the PAMPs, interesting because you come across them all the time. And I give you a little bit of previous information on PAMP and DAMP, and down below there's a little reference point for what I used. The important thing to remember really is PAMPs are pathogens, DAMPs are damage. So it's the danger model. And I think this is really nice, is that the danger model then, so anything can trigger it. So the DAMPs, like pathogens is really easy because it's a bacteria, virus, right? But the DAMPs is your damaged cell tissue. For example, like I mentioned earlier, the mitochondrial DNA got damaged due to a toxin. It starts floating around, and that can activate the danger model. That's a DAMP. So this is, I thought, a really nice diagram, which is why I put it in. And it says strangers and dangers. And I really like that. So the way to remember that is the strangers, which is your PAMPs, they're from outside the body. So it's a virus, it's a bacterial infection, it's a pathogen, right? Whereas a danger is, it's not a stranger because it's from your own body, but it's dangerous because it can then contribute to cytokine production. It can go into free radical, you know, all that lovely cascade that goes down. But so to me, I thought stranger and danger was a really nice way to remember PAMPs and DAMPs. So I'm hoping that it does the same for you. So it's like a damaged cell. They say a stress cell, but a damaged cell releases little bits. You've got DAMPs that join your PRRs, your receptors, and they activate the immune response. So that's your DAMPs essentially. Your PAMPs are the same, but it's a pathogen, so it's a stranger. So I'm hoping the stranger and the danger, stranger danger, helps you remember the difference between PAMPs and DAMPs, because that really stuck to me. And then the DAMPs can also be involved in autoimmune responses, and that's kind of important when we talk about some of the conditions that we're going to look at over the weekend as well. So different things intracellular or extracellularly can function as a DAMP. I've already mentioned a little bit, like a damaged cell that's flown around, for example. But what is interesting is that there's loads of different types of DAMPs, and one of the papers I read actually proposes different types, but they're really poorly understood, and whether they have specific roles or whether they all do the same thing. So again, it's a bit like Th17. We know they're there, we know they're important, we know they come from within the body, intra or extracellularly, but we're not quite sure about the different types or what they do. And then what Ben Brown at the NTY AGM, what he said, which I thought was really nice, systemic chronic inflammation is DAMP driven. So the inflammation is driving itself. Again, it's another cycle, because if you have inflammation and cytokines, they're going to eventually cause damage to the cell, a stressed cell. That's going to then release a DAMP. That's going to trigger the immune system, and that's going to trigger more inflammation. So it's this vicious cycle. And I smiled when he said this. He said this really early on in his talk, and I was like, this is perfect for my unit. So yeah, I think if you can remember stranger and danger, PAMP and DAMP, that the DAMPs can be involved in not just adaptive immunity, but also autoimmune response and tissue repair. We're not sure what the different types of DAMPs quite do yet, or whether they are in fact different. And then that DAMPs can drive systemic chronic inflammation, because the inflammation is driving itself. This leads us in then to the reactive oxygen species, and this is where I did a couple of my own mind maps for you, just so they're slightly different. So what can happen is, if we have loads of PAMPs and DAMPs, it'll cause an increase in phagocytes or phagocytic cells, and what they do is they produce reactive oxygen species. That production, right, generates hydrogen peroxide, H2O2. So it's the phagocytes doing what they're supposed to do, which produces reactive oxygen species in the respiratory burst that releases hydrogen peroxide, which is not good. So both of those, the hydrogen peroxide and the reactive oxygen species, can cause cell damage, tissue damage, right? Now, from what I've just said, what will that do? If there's more cell and tissue damage, what's that going to do? Well, it's going to release more DAMPs, isn't it? And if we have more DAMPs, we end up with more phagocytes. So this is one of the cycle, and I thought this shows it nicer than a written text. However, just to say that if we have sufficient antioxidants in the body, then this cell tissue and damage will not necessarily occur, because the reactive oxygen species won't have that effect. And I'm hoping I have it on the next slide. Sorry, next slide, I'll jump one ahead. What the antioxidant enzymes do that we talk about, which is your SOD and your glutathione peroxidase. So you can say superoxide dismutase, but really everybody says SOD. And catalase, what they specifically do is they help break hydrogen peroxide into hydrogen and oxygen, and then it's not going to damage the cells anymore. So that's why we want those antioxidant enzymes. So you can put in as much vitamin C, vitamin E, selenium, all the other antioxidants that you want, but it's these enzymes that we really, really need, because they are the ones that catalyze the breakup of this really damaging molecule into two harmless molecules, hydrogen and oxygen. So this is where these enzymes are really important. And some of these are reliant on nutrients. So for example, SOD is reliant on zinc, copper, and manganese, and glutathione peroxidase is reliant on selenium. So again, where do we know selenium from? The thyroid. So there's a lot of links between different systems in the body, where if you were to go in with a good multivitamin, say with zinc, copper, manganese, selenium, magnesium, B3, B6, vitamin C, you're doing loads already just from the immune system, but you're addressing other things at the same time. Let me just see if I can go back. I don't think I can. Hold on, yeah, I can. So that was the ROS, but also what was mentioned there was the COX enzymes, as I've already mentioned. But interestingly, if you put in an antioxidant, that can also help. So the most important one, kind of one of the biggest supplements would be NAC, which is N-acetylcysteine. So this is a really good one and has very, very, very little side effects. It's safe in breastfeeding as well. Now again, nobody's going to tell you it's safe in pregnancy, but I did recently check this for a client and then for myself as well, because I'm feeding the toddler, and NAC is totally safe to take. So actually Ben Brown got back to me. The company he advises, Pure Encapsulations, and they have a really good NAC. So again, if your COX enzymes are increased, if you put in NAC, that can have a big impact on the increase of the inflammatory cytokines and the ROS that's produced, which is lovely. And there was a little note in there about the CYP450 enzymes. And it is interesting. So when the CYP enzymes have done their job and they're kind of, it's like they're breaking up into the little bits, that produces reactive oxygen species, which can then contribute to oxidative stress. So there was just an example there, and I've given you the paper, one particular enzyme that was in rats, but it was CYP E2E1. sorry, I'm just thinking it's probably CYP2E1, I put in an extra E, was found to be overexpressed in rats in oxidative stress. So when the rats were put into oxidative stress, they started overexpressing this particular CYP enzyme. But that CYP enzyme could then create reactive oxygen species when it's being degraded. So it's leading, it's like that vicious cycle. Again, where do you intervene? Well, probably if you go in with a really strong antioxidant like NAC, and you put in the cofactors for the SOD and the peroxidase and the catalase, then you're going to be undoing a lot of the damage. The other thing though is that the CYP enzymes can be downregulated by inflammation as well. So I thought that was really interesting. Found this paper here, that's CYP3A4, which we know from estrogen, and it's not necessarily an enzyme we actually want, but it is downregulated by interleukin-6 when it's produced by tumors. So I thought this was really interesting, you know. So the CYP enzymes are affected by reactive oxygen species as well as cytokines, and they in turn can have an impact as well. So this is something I wasn't familiar with till I read through the PowerPoint to prepare as well. So just little bits of interesting. I know I'm flying through it. I'm very aware now that it's 9 o'clock, but you can go and read it. Linda, did you ask that question about the TFH cells? No, it wasn't. I'm trying to remember. Anyway, really sorry. The bits there, the TFH is beyond the scope of the course, so I'm not comfortable commenting on it because it's not something that I have studied or learned about. Even if it's involved in RA, what I've done is I've noted it for my review of the unit on RA. I will go and dig a little bit deeper on it. A very quick look didn't show me loads, so it definitely means I need to go and look at it more. But because it wasn't actually mentioned in the material, I said I can't go and look it up because it's extra material really. So what I did do is I had a really quick look and stuck in a bit of 2 links there. So where levels of THF cells are higher in RA patients than in healthy controls. So some of the papers are really recent. So and then one of them is slightly older. So I suspect it's an area that they're now starting since I think it was 2017, 2018. I suspect it's an area the research is now moving into. So bear in mind that the RA and NECFS was written in 2017. So it would have been based on kind of 2016 research. So that's why I'll look this up for sure. And if I find anything interesting, I'll share it on the forum, but it is unfortunately beyond the scope of it. And then it was just one of the diagrams that was attached with the circled mechanism. I didn't know where that slide was in our material. I went and looked, I don't know how many through PowerPoints looking for that one diagram. So if you
No,
just,
it wasn't.
It wasn't. Okay, so it wasn't from our material. Okay.
No.
Because it was driving me demented. And after an hour, I said to Moira, I said, I'm going to put a pin in this because I don't think it's our material. So what I can do is if I have a bit of work time left over at the end of the week, because I did use up 3 times as much hours as I should have for tonight, I will try and look into it for you, Linda. But it's just something like that, the THF cells, really interesting. I was reading it kind of going, ooh, yeah, definitely need to look at this more. But for the moment, park it for the unit, like, do you know what I mean? Like you won't need it for the assessments or anything like that.
Yeah, sure.
Basically.
Yeah. Good.
But thank you, because I do like learning loads of new things. There was the parasite question that was Patricia. So I didn't find much actually looking at the helminths, which I thought was interesting. So what I did was I popped in, found this article because I know you like reading stuff, Patricia. So I literally went, I'm running out of time, my kids need me. So there's an article for you. And I thought a really nice diagram that shows you what helminths can do in the immune system, all the different things it does.
Thank you.
But I did put in a little bit from it there for you. So it is suggesting that helminths have co-evolved with us, which makes a lot of sense, and they induce the immunoregulatory circuit. So I thought that was really nice. We want the immune system to regulate it. So it's a hypothesis, though, they're saying. So it appears it isn't conclusive, which I thought was interesting then that you said, having reviewed the 2 units, that you've kind of read both. And that shows it, because it's only a hypothesis. So they're basically saying infectious agents like helminths can be modulators of T cell function, but also dysregulation of subsets. So it helps to modulate T cells as a whole, but can dysregulate specific subsets like Th1 and Th17. So it might be good overall, but can then cause a dysregulation of the two specific ones. So it's like you're right, it does both. I think it's a positive and a negative. They are fundamental then in autoimmune processes, for example, MS, RA, and psoriasis. So I thought really interesting that there's an inverse association between the prevalence of certain ailments and autoimmune diseases. So it made me think that this is again something for our toolkit when you have somebody with an autoimmune disease. Go back to this paper. It has loads, as you can see, I left it in there. The reason I left this as a quote actually was to show how many references there are. And I think this might be something to then go back when you have that client to go back and say, well, do you know if you've ever had any parasites? You know, ask that client. So again, I thought it was a really good question, but slightly beyond the scope of the unit, but really interesting as always. So you keep me on my toes, people. This one, yeah, no, I was just parking that one, Patricia. Definitely beyond what you need to know, not only for the course, but also as a practitioner, I think. Again, it is something that I have the PowerPoint and I will go and do some reading on it. I didn't have much time. I think a lot of the time, if we get too reductionist, you know, if you're trying to, as a practitioner, you're not really going to look at the downregulation of the transcription factor. Do you know, like, it's more a case of the bigger picture. So, but yeah, no, I will definitely go and look it up, but it was definitely, I read that and I was like, no.
In my defense, I want to say that is because NF-kappa B has been coming out so many times, and you see so many things that is like upregulated.
Yeah.
And I found that sort of little line that was like, oh, that could be a gold mine. Like I might find something that actually bloody down-regulates the fella, you know.
Yeah,
but
no, and I'll have a look at it. But it's, the thing is with the research, of course, it's always, like I said, there's always something new coming out.
Yeah.
And you almost need to wait a year or two, if not 3, for more research to be there to get a better picture of it. So if something starts up in 2020 or even 2019, I try not to include it in, when I'm teaching a lot, I always think give it 3 years so that we have a bigger body of research, you know. But no, I will. There's a couple of questions, the 2 from you and Linda I have there, and they're in the back of my head, and over the next, probably won't be this week, let's be honest, because of lecture weekend, I will try and find something and add it to the form. So those were all the questions that you guys had, and all I did was, purely because I'm after reading that today, just came up from the British Medical Journal about vitamin D and COVID-19. I just wanted to give it to you because it's specific to the immune system, because Patricia had mentioned vitamin D. I just thought it was an interesting one to put in, and that if you do have time at all as an interest for your own sake, your own families, I would really encourage you to go and read up about vitamin D and respiratory infections. There's a lot of studies being done at the moment specifically with SARS-CoV-2. I know a lot of them are saying it's not specific yet, this is a review, so it's a really nice starting place, but they are actually taking place. There are studies taking place right now in a couple of places in the world, because the research is so promising. So I just think for your own sakes and your families, I would look it up. TCD in Ireland have recommended, I think it was the Tilda report, but they have recommended that every person should be taking vitamin D in Ireland with regards to COVID-19, even though it's not official guidelines yet, and a couple of other places are starting to recommend it. So I just wanted to flag it to you. I thought it was a good time to add it on to the end of the PowerPoint. So that is it. I'm really sorry I went so late, and anybody who bore with me, thank you very much. So what I'll do is I will